Conics or conic sections are intersections of a cone. They include parabolas, ellipses, circles, and hyperbolas. It's super easy to recognize conics by their equations, even if they're not in standard form. Let's start with circles. The general equation for circles is x minus h squared plus y minus k squared equals radius squared. To help you remember circles, remember these simple rules. A is equal to B, or x equals y, because x and y are the same value. If you look at the graph of a circle, you can see that the radius of x and y are the same, and that's what makes a circle a circle. Ellipses are similar, with one major difference. A does not equal B, and x and y are different. Look at the graph of an ellipse. The radius of x and y are not the same, otherwise it would be a circle. However, ellipses are also addition, and that's what makes them connected like a circle. Hyperbolas are the exact opposite of ellipses. They are subtracting, and whether or not x or y comes first determines the type of hyperbola you look at, a horizontal or a vertical. Finally, parabolas. It's easy to remember parabolas because only one term is squared, and depending on which term is squared also determines the type of parabola. Let's talk about the equation of a parabola for a second. Let's say that you are given an equation and 12 is your p-value. Set 12 equal to 4p and solve for p. Your p-value will help determine your focus and your directrix. However, the value given in the equation, for this equation 12, will determine how wide your parabola will be at the focus. Remember to go back in the book and review parabolas, foci, and directrices because this is a major part of being able to graph parabolas. Now we understand the equations for conics, so let's use that information to help us determine some conics. What is this equation? Well, it has two square terms, so it's not a parabola. And A does not equal B, so it's not a circle. And it's addition, so we can safely assume that this is an ellipse. Now look at this equation. We see that there's only one square term. That means that this is a parabola. And since this x is the square term, it's a vertical parabola. Now if y was the square term, we would have a horizontal parabola. Can you guess this equation? Pause the video and take a second to think. This equation has two square terms, so it's not a parabola, and a equals b, therefore this is a circle. Now we are ready to solve and graph conics. Let's look at the equation below. What is it? This is an ellipse. Now that you know that this is an ellipse, it'll be easier to solve for its standard form. Start by moving the constant over to the other side. Next, place like terms together. Take out the common factors and complete the square. Recall that completing the square means that you take the non-squared value, divide it by a half, and then square it. And remember when you're solving for equations to add terms to both sides. As I am completing the square, look at how I'm adding to 119. You have to multiply by the factor that you took out in the beginning, or you will not be adding correctly to both sides. Complete the square and place it in standard form, and then divide the common terms we took out. Watch what happens. We divide everything by 9 times 12. Here, 9 gets canceled, and 25 remains. And there, 5 gets canceled, and so 9 remains. And here, everything gets canceled, and we are left with 1. Here is our final equation. We use our x and y value to find the center of our ellipse, which is at 3 and 1. And we use our a and b to find how far we will travel. So if we have 25, we square it to get 5, and for 9, we square it to get 3. And there is our ellipse. Remember to go back in the textbook to review the different types of conics that we did not discuss in this video.